Hi, you guys. I think this is going to work a little bit better when I write out some of the stuff by hand and I'm not trying to write so much on this virtual whiteboard. Okay, so section 1.2. We're going to cover orders of operations and evaluating expressions. Both things that I know you guys have covered and have heard, but we're going to go over them. We'll go over it slowly. We'll do some example problems. And like I said, we'll always work on them in class. So Section 1.2 in your book is on orders of operations and evaluating expressions. Some of the definitions that I want you to find in your book are going to be power, exponent, and base. So you will go onto your book in section 1.2 and you will find those and you will write those definitions in your notes. Okay, let's get to doing some math. So we're going to start with exponents, and first thing we're going to do is simplify 10 to the power of 7, okay? So remember that when we're looking at this, 10 to the 7th power, we have something, if we have, like as an example, this is the one your book uses, 2 to the 3rd power. This right here, that's your exponent, and this is your base, and we write it out like this. So for these ones, I do want you to write them out so that it shows that you know what you're doing, right? This means that we have 7 tens. So let's see, we have 1, 2, 3, 4, 5, 6, 7. I know you can just in your calculator type 10 to the 7th power. In some of your calculators, I'm not sure what kind you have, but otherwise this is how we'd solve it. You can go ahead, use your calculator for this problem. You would get 10 million. Or you should get 10 million. Okay, we're just evaluating what 10 to the 7th power is. So if we have 0.2 raised to the 5th power in the second example here, I'm going to do 0.2 times 0.2 times 0.2 times 0.2 times 0.2. Okay, I have 5 of those. If I put that in my calculator to solve, I would get 0.00032. Okay, this right here, this is the work that I will be looking for in your notes. These answers I will also be looking for, but in your notes and your homework, make sure that you're doing both of those things. Okay, so pause the video and try these problems. Okay, so hopefully for 3 to the 4th power, you did 3 times 3 times 3 times 3, and hopefully you got 81. For this one, you're going to do 2/3 times 2/3 times 2/3. Okay, and if you forgot how to multiply fractions, remember you're going to multiply across the top and across the bottom. So I would have 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. 3 times 3 is 9, times 3 is 27. 8 over 27 is the answer you should have got for that one. If I give you something in a fraction, please give it back to me in a fraction unless I tell you otherwise. Don't change it to a decimal. Okay, this one, 0.5 times 0.5 times 0.5. And I should get 0.125 as my answer for that one there. Okay, next page. So we're going to start to use the orders of operations. Sometimes people learn this as a different way. I learned it as PEMDAS. That's how I teach it. So PEMDAS stands for P parentheses E exponents. The M and D really could be like together. If I should probably just add in, let's see, some little parentheses here and here, because it's multiplication in order from left to right and addition and subtraction from left to right. So it doesn't mean multiplication before division. It means that multiplication and division is done from left to right. So let's do a couple of these. Okay, this first one here says 6 minus 2 to the 3rd power divided by 2. So first I want to do P, what's in parentheses. So in this case, that would be 6 minus 2. I'd get 4. So after my first step, I have 4 to the 3rd power divided by 2. Next, I have exponents. 4 to the third power, remember that's 4 times 4 times 4. So I would get 4 times 4 is 16 times 4 is 64. So I'd get 64 divided by 2. And if I do that, I get 32 as my final answer there. Okay, the B says 2 to the fourth minus 1 divided by 5. Okay, so let's do this with using the orders of operations. So I don't have any parentheses, but I do have exponents, so I need to do 2 times 2 times 2 times 2, which ends up giving me 16. Okay, so I get 16 minus 1 divided by 5. Now here I look and I say, okay, I should do multiplication or division from left to right, but the problem is that I have this whole expression on the top, that whole thing divided by 5. So I'm going to take care of what's on the top and bottom of my fractions before I take care of the whole thing. So I'm going to do 16 minus 1 is 15, and then I have 15 divided by 5, which is 3. I can't do this as, or I could break that up as 16 over 5 minus 1 over 5, but that makes it a lot more complicated to do it that way. And we haven't really gotten back into breaking up fractions, but you can work on what's on the top of the fraction and on the bottom of the fraction, and then take care of the fraction itself, which is in this case division, or we can use division to simplify it. Okay, so on this one, we want to replace letters with numbers to simplify when we're evaluating expressions. So if I ask you, what is the value of the expression for y equals 5, or sorry, x equals 5 and y equals 2 of this first one right here? So it says x squared plus x minus 12 divided by y squared. Sounds like a lot happening, a lot of variables, but all I'm going to do, since I have x equals 5, plug that into both of those spots where I have x. So instead of x, I'm writing 5 squared plus, and then instead of that x, plus 5, right? Then I have minus 12 divided by, now see y is 2, so I'm going to plug that in right there to be 2 squared. Now I just use my orders of operations, and so it's the same as before. So do we see any parentheses when we think of PEMDAS? And I don't see any. Then I'm going to take care of my exponents. So here's an exponent, here's an exponent. So I'd have 25. And I'm just going to write out the expression as is, just taking care of those exponents. 2 squared is 4. Now remember, multiplication and division. I do see division right here, so I need to take care of that first. 12 divided by 4 is 3. Now I only have my addition and subtraction left, that's right here. Remember, it's addition and subtraction from left to right like you're reading a book. So let's do 25 plus 5, which would give me 30. And then I can do minus 3, so my answer for this one would be 27. So hopefully you also got 27 there. Okay, this one. So we're still going to use x is 5 and y is 2 for this right here. Okay, so let's rewrite that. X is 5, y is 2, and then let's solve this one. So I'm going to plug those in. So I have 5 times 2 on the inside, squared, divided by 5 times 2. Okay, I just plugged in 5 where x was and 2 where y was, because that's what it told me to do in the rules. Now let's take care of this in orders of operations. When I'm looking at my PEMDAS there, my parentheses need to be taken care of. So I need to do 5 times 2, that's 10. And then 5 times 2 over there is also 10. So I have 10 squared divided by 10. Now I can do exponents. 10 squared, that's 100, divided by 10 gives me an answer of 10 like that. All right, let's go over this word problem. It says What is an expression for the spending money you have left after depositing 2/5 of your wages into savings? And then we want to evaluate for your weekly wages of 40, 50, 75, and 100. So let's start with the first question. What's an expression for the spending money you have left? So we're trying to find how much spending money. Let's call that S. After depositing 2/5 of your wages into your savings. Okay, so wages is going to be our other variable, and we're going to say that that's W. Okay, so we want to know what our spending money is left. So our spending money would be our wages if we didn't deposit any, right? If we made that much money, that's our wage, that would be our spending money. But we need to take away what we put in our savings. And what we put in our savings is going to be 2/5 of our wages, right? That's what the question tells us. So I have this expression, S is our spending money equals W minus 2/5 W. Okay, that's my expression that I have to model how much money I have left after the amount of money I take and deposit or save 2/5 of that amount of money. Okay, so I can make a chart. Wages. Then I'm going to put this expression in here to solve that. And what I have left is S. So my different amounts of wages, right, were 40, 50, 75, and 100. Okay, so if my wage was $40, I can plug that in for W, and I get 40 minus 2/5 times 40. And then I would get what I get for my spending money. So if I wanted to do 2/5 times 40, or solve this problem like this, right? 40 minus, remember I can make this over 1. 2 times 40 is 80 over 5, like that. And if I do 80 divided by 5, 40 divided by 80 divided by 5 is 16. So I get 40 minus 16 to get 24. So that's what I have left there. Okay, likewise, I can plug in 50 here to the same thing. 50 minus 2/5 times 50 and solve that. 50 minus 2/5 times 75. 100 minus 2/5 times 100. And if I solved all of those out, that's what I'd get as my answer. So you'll have quite a few word problems to work through, and we can go over more in class, but here's an example of that one that we have there.